All right, you said you needed help on number 8 from 8.1. So I'm just doing this quick video on notability, and I'll write the problem here. So it says identify the transformed values of the reference points and the asymptote from those of the parent function for the given function, then graph the function. Okay, so this is what they give you on the screen. G of x equals 3 times 2 raised to the power of x plus 1 minus 2. So the first thing that I'm going to do is I'm going to start listing out the things that I know for sure. So because of this number right here, I can say that my k equals -2, which also means that there's an asymptote at -2. So then from there, let's see here. So our initial reference point, well, let's go back. So we can also figure out our h. So if you remember, our generic function looks something like a times b raised to the power of x minus h plus k. So that plus 1 would be this part right here. And so that means that our h value is a -1. So just to double check, if I put -1 in there, that does turn into plus 1. So I'm good to go on that part. So then from there, you can actually start to figure out your reference points. So part A says identify the transform values of the reference points from those of the parent function for the given function. Enter the correct coordinates in the boxes. So step 1, we know that our first reference point we can use to find h. Let's see here, what color do I want to do? We'll switch to purple. And so because we have this x plus 1, that's also where we get our h from. So in order for our first reference point, that's always when that x minus h goes to 0. So our first reference point is going to be at x equals, 1? So when I plug 1 into this equation, this whole part goes to 0. And that's how I would solve for A if we were doing some of the problems that we did in class. So, okay, if we have the x... I'm sorry, that's wrong. X would have to be -1. Because again, if I plugged it in there, it would have to go to 0. So hopefully you caught that. But again, if we plug that in, it has to go to 0, and that's how we'd be solving for A. So then from there, we could honestly just plug the x equals -1 into there and solve. So that would give us our y. That would be our first reference point. So that's going to be like, so y equals 3 times 2 raised to the 0th power, because that's the whole point. That's going to go to 0. Minus 2, so then we've got 3 minus 2, so then y equals 1. So our first point is -1, 1. So that's how you find your first reference point. Your second reference point, because this function is an exponential growth function, and I know that because that number right there is greater than 1, my second reference point is always at 1 unit to the right of our first reference point. So 1 unit to the right of that would make our x equal 0. So once I know that, again, we can just plug that back into g of x. So then we're going to have 3 times 2 raised to the power of 0 plus 1. And again, I'm plugging it into this equation right there, minus 2. So then when we simplify that, we've got 3 times 2 raised to the first power, which is also just 2. So then we've got 6 minus 2 equals y, and then so then our y equals 4. So then our second point would be 0, 4. So this is your answer for part A. -1, 1 is your first reference point. 0, 4 is your second reference point. Let's see here. So part B says identify the transformed value of the asymptote from that of the parent function. Your asymptote is always your k value. So you would just type in y equals -2 for that one. And then when you're graphing it, so part C is kind of a, pick your multiple choice thing. So you're going to pick the graph that has an asymptote at -2. So one of the options has +2, the other 3 have -2. But then you're going to pick the graph that has these 2 points in it that we've already talked about. So you'll have one point at -1, 1, and then another point at 0, 4, which is also the y-intercept. So let's see here. -1, 1, and then y-intercept. So there is an option that shows that. So that's generally how it would work for a problem like that. So again, this generic function, I'm going to highlight it in green now. So this thing is really important and really powerful, and you should definitely know this for tomorrow. So hopefully this helps. Other than that, I'll see you tomorrow. Again, if you have any more questions, feel free to text me.